Okay. Good evening, guys. So what I've done is, of course, Wednesday, yesterday was a public holiday, so we lost our tutorials that were scheduled for Wednesday. Usually we don't replace classes we have lost on public holidays unless we have lost too many classes and we are not able to cover the syllabus, then we replace. The reason is, you all know we have a lot of challenges here, classroom availability, and that's why you have 6 to 7. Last year it was 7 to 8. 7 to 8 class, and by the time I leave the classroom after clarifying doubts, it will be already 8:30. Yeah. So classroom availability, and you are in different. You take different modules, different groups, bring them all together. Is a challenge. But don't worry, we have lost yesterday. If we lose many classes, then definitely we will replace it. Okay, so don't worry. Syllabus coverage is the lecturer's problem, not your problem. So don't worry. Okay, yeah. If we happen to lose one more tutorials, then we will definitely replace, because we need to catch up the syllabus. Okay. So what happened on Tuesday was we discussed. Let me share so that I am not talking just in thin space. So we were dwelling with language and grammar. So in the Tuesday's tutorial class, I discussed the answer for question 1A and 1B as well. And I gave direction for 1C. And I remember one of my tutorial class, I also gave the answer on the board. Okay? Yeah. Anyway, I've given direction for 1C. So I presume it is the same coverage with the tutor Yogeswaran as well, because when I stepped out, he stepped in. So I told him I have covered the example problem and question 1A, B and C. Okay. So 1C is only direction. Huh? Yeah. So what I will do is, today I am going to discuss 1D. Okay. E, F and G, I will do it in the tutorial. Okay. After doing 1D, I will jump to 2C. 2C, I will give you directions for 2B, and 2A will be a take-home exercise. So with that, we are done with the tutorial. Okay? Yeah. So next week, we will complete the tutorial during the tutorial class. And any doubts you have, I will clarify on next Thursday during the lecture class. Okay? So with that, with next week, we will wind up with tutorial 1, and the following week, we will jump to tutorial 2. Okay? All right. So let me jump to 1D. Yeah? So what 1D says is, set of strings that are element of A or B clenista, where the string has greater than or equal to 3 B's. Okay? Yeah. So I think I told you, I'm not going to say this repeatedly in every class. Okay? Please excuse me, and I apologize. Okay, I cannot do more than that at my age, okay, and my experience. I am coming to the ground to say this. We meet only 1 hour, whether it is lecture or tutorial. Okay, so in this 1 hour, I want to mean business. Mean business means I am paid to teach you. Okay, so I want to just do that, because 1 hour is very limited, and I want to value add in that 1 hour. So what best I can give in terms of teaching and make you learn, I want to do it in that 1 hour. Okay? So I don't want to waste that even a few seconds or even a minute saying this repeatedly in every class. Okay? So those who are worried only about attendance, you just email me, subject line, just say attendance, this date, I give you. Don't worry. I don't want you to be here just for attendance. Okay? So that, you don't feel annoyed I don't like to hear this nonsense from Raja. At the same time, I don't want you guys to disturb me because I want this 1 hour packed to discuss my subject. That's all. Okay? So I mean business, and I want you guys also to mean business, because this subject, you need somebody to help you to learn. Okay? So if you can learn on your own, then you are the best of the best. I have no issues, but that will be very, very few cases. Okay, exceptions. Exceptionally brilliant brains who will be able to learn on their own without attending any of my classes. If you are so, please do so. I have no issues. Okay, I'm not an attendance pushy guy. As I said, if you want attendance, just tell me, I'll give you. No issues. Okay. All right. Let's jump into this. So as I said, I won't repeat this every class. With this today, I'm done. I don't want to bore you giving you advices or instructions. Okay. All right. So what this specification says is, language specification says is, set of strings that are element of A or B clenista. The vertical bar means where, W-H-E-R-E, where. W stands for string, where the string has greater than or equal to 3 B's. Okay. So this element of, I explained in the tutorial, it means member of. That is, every string in this language is a member of A or B clenista. A or B clenista means the string can be made up of any combination of A or B. So what is the length of the string? The length of the string is defined by this clenista. So depending on the value of the clenista, the length of the string is defined. But we have something more here. Yes, the strings are made up of the alphabets A or B, but what pattern of strings that this language accepts, or what pattern of strings this language produces? The string has greater than or equal to 3 B's, that's all. Meaning, as far as there are at least 3 B's, minimum 3 B's, or more than that, it is fine. So I know, I've been a student, I'm not straight away from sky as a professor. Okay, so I've gone through what most of you experience. So you may want to see examples. Can you show me example pattern of strings? That's the next step we are going to do. So this will help you to understand better what pattern of strings this language can produce. So I simply say valid strings are, or I say example better, because we are not going to write all the possible valid strings. So I just say example valid strings are. So the specification says at least 3 B's, greater than or equal to 3 B's. So at least 3 B's, minimum 3 B's. So I'm going to take, see, when I look at example strings, I look at the minimum possible string. Minimum possible means what is the minimum length possible, or the smallest possible string first. That's better to say. Okay, I look at the smallest possible string. So to me, the smallest possible string will be simply triple B. Okay, 3 B's. So minimum. So it says greater than or equal to 3 B's. So the equal to says minimum and greater than says maximum. So maximum is how many B's? Infinite B's. So I'm just going to say I can have as many B's as possible. I did not even count. Any number of B's is possible as far as there is minimum 3 or more than 3. Okay. So this is a possibility with purely B's. Purely B's. Okay. Purely B's. And what about A's and B's? So I can have something like this, A followed by 3B. We say any combination, it means the A need not appear in the front, A can appear at the end as well. So I can have something like this, not necessarily like this, I can have something like this as well, A, B, A, B, A, B, A. So if you observe carefully, I have 3 B's minimum, but I have inserted an A in front as well as at the end of or the back of every B. So an A can appear before as well as after a B. Does not matter. Okay. So should I have only one A's? No. You can have as many A's as possible. You can have something like this as well. I just say etc. So what I'm trying to say is, you can have any combination of A or B. The only requirement is the string should have minimum 3B, that's all. Any combination, the minimum, there should be 3 B's, that's all. If there are minimum 3 B's, then the string has met the language's specification. Okay. So now we are going to translate this thought into production rules. So why we call the grammar as production rules? Using the production rules, we are going to produce strings that are in this language. That are in this language means that are valid in this language or that are member of this language. Okay. So I am going to translate this thought into the grammar. Okay. So I just write SS because S stands for the start rule. You always start with the start rule. Okay. SS, and if you have observed so far, I have always taken the smallest possible string as my first rule. Okay. So I am going to just copy and write it here as my first rule. But if you observe, if my grammar is that's all, S is triple B, I would be able to produce only this. Correct, right? I can produce this string, but I won't be able to produce these strings. So I need to improvise my answer. Okay, I need to improvise or tweak my answer such that I can produce all possible strings that are in this language. Okay, so how to do that? So I'm going to apply the look ahead mechanism. Okay, so this is always I always compare this with the chess game. Chess is a beautiful game, very first game that applied the concept of AI when it was automated. Okay, chess programming. Okay, so why in the sense, chess is a game very matured. Okay, usually it is we call it as a sum zero game. So one person wins, the other person loses automatically. So there is no profit or gain here. Okay, one person's gain is the other person's loss. Right? It's zero. We call it as a zero sum game. Go and Google to understand better what is meant by zero sum game. Okay, so it's a zero sum game. I just explained in simple terms what is zero sum game because zero sum game is not the topic of this subject. So, but why I went for chess as an example is, even forget about programming, playing with a computer, a chess game. Just look at a simple example of layman's, two people playing physically or manually the chess game. So normally what happens when I make a move, the opponent will make a move, right? So if we are players, you always have some program here. Program here means so you would have observed some people they move the pawn first, 2 squares up. Okay, some people move the rook first, diagonally 3 squares. They always have a program here. Okay, I move this step, the opponent will make a move like this. If the opponent makes a move like this, then I will make a move like this. Okay, then if the opponent makes a move in response to my move, then I will make a move like this. If you are not a professional player, you go and sit with a professional player. In 7 or less than few steps, he will make you to lose the game because he already has the steps in mind. So for every move he makes, what move you will make and what will be his response move. So it is like a look ahead table, The algorithm is already there. Okay, because chess, as I said, is a very matured game. So every coin, okay, you have what are the valid moves? It's just an 8 by 8 square. Okay, and since the valid moves are there, and even the World Chess Federation, they actually define how to record every move. It actually follows a matrix, a table. Okay, so what I want to say by saying this chess game is always look ahead mechanism. Look ahead mechanism means if I make a move, the opponent is going to make this move, possibly this move. If the opponent makes possibly this move, what will be my move? So I have already looked ahead. What will be the moves that you will make, and accordingly what moves I should make. This is actually a professional player does. Okay, so same look ahead mechanism we are going to apply. Look ahead mechanism means I am going to think a bit far to see what are the possible pattern of strings so that I can write my rules. So what is the look ahead mechanism I'm doing is I'm looking at all these possible strings. So if you look at this, it is just one step ahead of this. Instead of triple B, I have A triple B. Okay, so I also told you not necessarily I need to have one A, I can have many A's. Correct, right? So let us look at one A first, and maybe and again parallelly many A's. So what I'm going to do is, I want to produce this string. So I may take it as ABB. If I take it as ABB, then I cannot produce this, I can only produce this. Correct, right? I cannot produce triple B anymore, I can only produce A triple B. So I'm thinking ahead. Hey, I want to produce triple B and I also want to produce A triple B. So what I can do? Think ahead, huh? So I'm going to replace this A with capital A. Capital A is a non-terminal. Non-terminal means it can be expanded. So the next step, I'm going to expand how I can replace A with. How I can replace A with. Again, think ahead mechanism. Huh? So by doing this, my thinking ahead is in this direction. So if I want to produce triple B, I will simply say A triple B. Okay, by applying the rule S is A triple B. Now I want only one A, so that I can have A triple B. But if I apply this rule, I will end up with A, then triple B. So again, my think ahead mechanism. Hey, I want to eliminate this fella, capital A, so I can get A triple B. At the same time, I need not have A triple B, I can have any number of A's. 2 A's, 3 A's, 4 A's, 5 A's, any number of A's, before the B. Okay? So again, thinking ahead. So what I'm doing is, I'm putting a rule here. How to eliminate the capital A? Simply by lambda. So lambda means, it represents empty string. Okay? So now, in this step, I can eliminate the capital A applying the lambda rule, replacing capital A with lambda. I will end up with A triple B. Okay? So if I want to produce many A's, I can do so. So for example, A triple B. I want to produce many A's before the B. So I can say AA, keep the triple B. The next step, A. I replace the A with AA again. The 3 B's remain. This 2A remains. Again, I replace capital A with AA again. The 3 B's remain. Maybe now I am tired, I want to eliminate the A. So I use the lambda rule, eliminate the capital A. I end up with triple A, triple B. You see the look ahead mechanism, huh? Yeah. So I want to, using one production rule, I want to produce as many similar strings as possible. And that's what I'm trying to do here. Okay? So I can produce one or more A's by having this rule. Okay? So now we are going to reflect this thought with every B. If you see here, if you see this string, I have an A before every B and after every B, If you see here, I have an A before this B, an A after this B, and I have an A after this B as well. I have an A after this B as well. So I'm going to apply this thought here. So once I've applied this thought, then to me, any valid string is possible. So what I'm going to do is, I'm going to improvise this, looking at this string. Okay? So when I look at this string, this is also is going to be parallelly possible, I'll show you. So I'm going to insert a capital A after every B. So if I want to produce this, it's going to be a breeze for me now. I'm going to produce that string and show you. So AB, 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 A. I apply this rule. I want AB, 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 A. So this A, I'm going to replace with AA. Right? So whatever remains after that, they remain as it is. I told you, even though we can see the final string, don't jump. We always do one step at a time. Okay? So next step, what I do, after the A, I want to have a B. So this A, I need to eliminate. I can apply the lambda rule here. A is AA or lambda. So I can replace this capital A with lambda, so that I will end up with A, B, A, B, A, B, A. So the next step, what I do, I already have AB now. So after this AB, I want to have a small a. It can be done, right? AB, I'm going to replace this A with AA, applying this rule. A is AA, applying this rule. And whatever remains here, they remain as it is. So in the next step, what I can do, A, B, A remains. Now I am going to replace this A with lambda, so that I can get A, B, A, B, A, B, you know. So I'm going to replace this A with lambda, huh? So A, B, A, B, A, B, A. So in the next step, A, B remains. I'm going to replace this A with AA again. AA again. This BA will remain as it is. So now A. I'm going to eliminate this A with lambda. So I will get BA. The next step, AB remains. I am going to replace this A with AA now. AA. And in the next step, I am going to eliminate the capital A with lambda. So I will get AB. So I have got this. Okay. So now the question is how to produce this. Okay. How to produce this. And I can have something like this also. I am simply producing some string. I am not even applying my brain here. Because definitely this string has more than 3 B's. So it's a valid string. Correct, right? So my thought is how to produce this and produce this pattern of string. It's easily possible. I just need to do something. So let me look at purely B's. If I look at purely B's with this, let me show you. S derives AB. I'm going to apply this rule. When I apply this rule, even if I put all B's capital, AB, okay. Even if I eliminate all the A's with lambda, if I eliminate all the A's with lambda, I will get only 3 B's, after a few steps. Okay, every step I eliminate one capital A. Okay, replacing it with lambda, applying this rule. A is lambda. So I can replace this with lambda, I will get BA. Then I can replace this A with lambda, this A with lambda, this A with lambda. I will end up with only 3B. But how to produce this B? This string. I don't need to count how many B's are there. I want to produce this string. So meaning I want to have more than 3 B's. So how to do that? So what I'm going to do is, I'm going to add a rule here. Again, think ahead. I am looking at this. Parallelly, I am looking at this as well. I have more than 3 B's, but many A's as well. A mix of many B's and many A's. Mix of many B's and many A's. Okay. So I'm thinking something like this. When I write AA, I'm going to write BA now. You will understand shortly when I show in terms of derivation here now. Okay. So what I can do is, I can replace this A or eliminate this A with lambda. So I will get BA. Yeah? The next step, I am going to eliminate this A with the lambda. So I will get BA. The next step, I am going to eliminate this A with lambda. So BA. I have eliminated this A also. If I eliminate this A, I will end up with triple B. But I want many B's. Okay, more than 3 B's. It could be 4B, 5B, 6B, infinite B's. Okay. So what I'm going to do? Now I'm going to jump here. I have a rule here. A is BA. Correct, right? So I can write this. Derive now B. I'm going to replace A with BA now. A is BA, right? Replace A with BA. You see? Now I'm trying to expand the number of B's. If I want to stop with 4B, I can eliminate this A with lambda. If I want to have more B's, I keep expanding A as BA. A is BA until I want to stop. Okay? So maybe I'll show you one more step. So I already have 1, 2, 3, 4 B's. I'm going to replace A with BA again. Maybe I want to stop. I'm just happy with 5 B's. 1, 2, 3, 4, 5. I eliminate A with lambda. So I told in the tutorial, some of you may ask, why you are not putting the lambda here? Lambda is only a symbol which represents nothing, empty string. Okay. So that's why I use the word eliminate. I'm eliminating A with nothing. That is using the lambda rule. Okay. So I get 5 B's. So you can produce any number of B's you want. Okay. So what happens if you want to produce this? It's simple. After 3 B's, I copy up to here. I want to produce this string. So after 3 B's, I actually have 4 A's. So what I can do here, after this, after 3 B's, I want A's, right? I want 4 A's. So I can replace A with AA now. I have this rule, A is AA. So I can replace it with AA. The next step, triple B A. I'm going to replace A with AA again. In the next step, triple B 2A. How many A's do you want? I want 4 A's. So I'm going to replace the capital A with AA again. The next step, triple B 1, 2, 3, 4 A. The next step, I'm going to stop now because you know where I'm heading to. I have done up to here. See, the text editor, why you are seeing so many red underlines? The text editor for Word is sincerely doing its job, because you see the language here at the bottom. No, it's not working. Okay. If you see the bottom here, it says English. You can see here at the bottom. Right. So the text editor strictly looks for grammar applied to the English language. Okay. So to the text editor, all these with red curly underlines, they are not valid strings in the English language. Of course, triple B is not a word in English. B is an alphabet in English, no doubt about it. But there is no word in English, triple B, because triple B has no meaning. Semantically, to me, to say is some nonsense. Okay? To me, we call this as gibberish. I mean, we are using English alphabets to frame words, but these words does not have any meaning. Gibberish. Okay? So all these are gibberish, not valid strings in the English language. That's why you see the curly underlines. Okay? Now mind, let us not go there. I cannot switch it off. I can only choose language. I cannot switch it off. So no way to do away with this curly underline. Only way is for every string I have to go and kill that red curly underline. So if you see here, I have already produced triple B 4A. That is, I have produced up to here. Let me do this. Okay. So I have produced up to here. So now if you want this many B's, you start replacing the capital A with BA. A is BA, A is BA, A is BA, until you want that many B's. Then again, A is AA, A is AA, until you want that many A's. So I'm done. So this is my answer. Okay, so this is the answer. And I told you in the test or exam, what is in the orange color box carries marks. Okay, so do we have marks for these? No. You can do it in rough work, or as I said, you are a brilliant brain. You can do the derivations mentally. You can do so. I don't care. Okay, I just want to see this answer. That's all. Okay, but to me, even me, I cannot see many derivations here. Okay, certain derivations I can do it here. Certain derivations are tricky. I still need pen and paper. Okay, so you can do this in your rough paper, or the paper that is allocated for rough work in your answer script. Okay, but to me, without doing this, you will not be able to verify whether your grammar is right or wrong. Whether you obtain the right grammar, you have to verify taking some example strings and see whether you can derive them. To me, the best way is, I call it as a hard test. Hard test means I only verified valid strings. I did not verify invalid strings. Correct, right? To me, you should test one invalid string as well. Invalid string means try to produce an invalid string. If your grammar can produce an invalid string, your grammar is wrong. Your grammar should not be able to produce an invalid string. Okay? So, what can be invalid strings here? So, I am going to give some invalid strings here to show you a hard test. Hard test means a thorough test that your grammar is perfect. So, I'm just going to say example invalid strings, because we are not going to see exhaustively all possible invalid strings, just a few example invalid strings. So, purely A's, I'm not even counting. Purely A's is an invalid string because the specification says you need to have at least 3 B's, 3 or more B's. Correct, right? So, I cannot have purely A's. Can I have 1 B? Cannot. Can I have 2 B? Cannot. I can have 3 B's. Right? Not necessarily like this. Can I have AB, Abba, or Baba, black sheep? Baba, curry masala? Cannot. Even though these last 2 strings have a B, but there are only 2 B's. Correct, right? You should have at least, all these are invalid strings. To me, this one I can show you working mentally here. If you look at your grammar, your start rule itself has 3 B's, There are 3 small B's, You can only eliminate the A's. You can eliminate the A's with the lambda rule. So if you eliminate the A's with the lambda rule, what I've done here, or maybe I'll show you. Yes derives. To me, this is not possible, so I remove this. This is for explanation. Because this is how I derive the grammar. So if I want to have, see, don't forget, I cannot go to A directly. I cannot go to A directly. I can go to A only through the start rule. From here I can go to A. I cannot go directly to A. Okay, that's why we call the first rule as the start rule. We put the S there. We should always start from there. You can't jump directly to A. Okay, so this is the standard definition across the world. That's why we call the first rule as the start rule. We always should start from the start rule. So when I write the start rule is like this, I can eliminate the A's. If I eliminate all the 3 A's, I will end up with 3 B's. So no way I can produce purely A's. No way I can produce 1B. No way I can produce 2B. No way I can produce Abba. No ways I can produce Baba. Okay? The minimum possible string I can produce with the start rule is triple B. Okay? So I can run the derivations here. So if you ask me, sir, do I need to show the derivation? No need. As I said, I don't care. To me, I only care for the solution, the grammar itself. But as I said, if you want to verify whether you have written the grammar rightly or not, no choice, you have to do some derivation and see. Okay? So you are trying to verify and validate your answer. Remember, that's why I told in the tutorials, I told in the first class, today also I am telling you, for this entire module, every answer you yourself can verify. You don't need to come to me and ask me, sir, I have done the grammar, can you check for me whether it is right or not? No need. You don't need to come to me. Okay? You don't need to come to me, or no need to go to any expert. You can verify by checking with a few valid strings and 1 or 2 invalid strings. If your grammar can produce valid strings, and if your grammar cannot produce invalid strings, then your grammar is perfectly right. You don't need to go and verify with anyone else, including me. Okay? So you yourself can find out whether your answer is right or not only for this topic, all the topics until the end that we are going to discuss. Okay? 9:37. So I'm afraid whether we can do. Okay, let me try and do second. I'm jumping to 2C. E, F and G, I will do it in the tutorials. So similarly, Yogeswaran will do in the tutorials E, F and G next week. Okay? So I'm jumping to 2C, this one. You see now the language specification is different. There is no more curly braces, there is no more W, but we still have Clenesta. Okay? So what is this? So before we go here, let me open the attendance before I slip sharing camps. Because like last week, I don't want you guys to rush marking attendance in the last 1 or 2 minutes. If we do this now, we are safe. Okay, here you go. So there is a lot of ghost attendance, huh? Ghost attendance means, I know not all 154 are here in the class. It will be hardly less than 100. So done? Those who are still marking, so you can follow the passcode here, so that we don't waste time. So I switch back to the tutorials. So those are still marking, you can just follow the just follow the passcode on the whiteboard. Okay, so I'm going to jump here. Now I need to discuss something with the help of slides. Take care. Health is very important. All right, let's jump. Don't get me wrong. The situation, you see, we just discussed one topic is already 6:40. Just 20 minutes. I thought of finishing this problem. I don't know whether I can finish before 7 or not. This is my challenge. Time, very, very short time we have. So I cannot even spend a few seconds talking outside the subject. It's very challenging. Now, let us not go there. Okay, so just now we saw the problem You did not have the curly braces, you did not have the W, So the language specification was completely different. Okay. So what you saw was some brackets. Then let me share again those who are. You see, here the language specification is you have brackets, open brackets, closed brackets. You have Crenesta, and you also have union operator. So only thing is familiar is alphabets A, B, C, and Crenesta. Suddenly you don't have curly braces, you have brackets, and you have the union operator. Okay, you have the union operator. So why suddenly the language specification is in a different format? So these language specifications are called. Suddenly you don't have curly braces, you have brackets, and you have the union operator. Okay, you have the union operator. So why suddenly the language specification is in a different format? So these language specifications are called as regular languages or regular expressions. So you need to know what is a regular expression and what is a regular language, and that's why I jumped here, so that later you can refer to the slides to make more sense if you could not follow what I explained in the class. Okay. So, like we said, lambda represents the empty string. We have phi, fi, not pi, pi, fi. You see the symbol here. So, phi represents the empty language. So, you have phi here. Phi represents empty language. And what is a regular expression? Regular expressions are strings over the alphabet, open bracket, close bracket, phi, lambda, union operator, Crenesta. That is, whatever your symbols you see within the curly braces here are the alphabets that are used in the regular expression. So, regular expression are going to be strings that are made up of the symbols open bracket, close bracket, phi, lambda, union operator, Crenesta, union sigma. Union sigma means these symbols here, open bracket, close bracket, phi, lambda, union operator, Crenesta, these symbols can be combined with, that's what this union operator means, can combine with sigma. Sigma stands for alphabet set. Okay. So alphabet set for English language is A to Z, I've given here. This is sigma for English language. This is sigma for the Greek language. This is sigma for binary language. This is sigma for the number system, decimal number system. So sigma is nothing but set of alphabets defined by a language. I have given here. A string over an alphabet sigma is a finite sequence of symbols from sigma. In layman terms, sigma represents the alphabet set. So sigma for English language is A to Z. Simple. Okay. So we can combine any of these symbols with the alphabet set to form a regular expression. And a language is regular if it is made up of regular set. What is regular set? This is a regular set. Whatever symbols you see within the two curly braces, that is the regular set. Okay. So regular expressions are made up of these symbols, which can be combined with sigma, with the alphabet set. Okay. So a language that uses a regular set is called as a regular language. That's all. So all these languages you are seeing here, A, question 2A, 2A, 2B, 2C, these all are regular languages. So now the question says, for each of the regular expressions, see, regular expressions. A regular expression means it is made up of alphabets combined with some regular set symbols. Okay. Write a regular grammar that defines the same language. So far, we only saw grammar. We did not see a definition regular grammar. If you see question 1, it says for each of the following languages, construct a grammar that recognizes it. It didn't say regular grammar. Okay. So now we have to understand what is regular grammar. Okay. Regular expression we know. What is this? This is set notation. Language specification. Language has been specified in terms of set notation. So here in question number 2, language is specified in terms of regular expression. And the question is asking you to write regular grammar. Okay. So the examples we saw, whether it is regular grammar or what. This is a regular grammar. The answer given for 1A is the regular grammar. The answer given for 1B is a context-free grammar, CFG we call it as. The answer we have given for 1D is also a context-free grammar. Okay. So we need to understand now what is context-free grammar and what is regular grammar, so that we can answer the question 2A, B as well as C. Okay. So I have given the definition here so that you don't forget, because if I say in thin space, after some time you will forget. Even if something told to me one time, I will forget after some time. It's nature. Okay. So what is a regular grammar? If you, I'm going to explain with this example. Later you can read whatever I explained. I have given the definition. So just now I told you, this answer is actually a regular grammar. In regular grammar, on the left hand side of the rule, you always have only one letter. In a regular grammar, on the left hand side of the rule, you always have only one letter. How about on the right hand side? On the right hand side, you can have one letter. For example, lambda is one letter, or at the most you can have two letters. I repeat one more time. Regular grammar means on the left hand side of the rule, you can have only one letter. That's what we are seeing here. S is one letter, E is also one letter. On the right hand side, you can have minimum one letter. It could be just lambda, or it could be simply small a or small b, possible. And on the right hand side, at the maximum, you can have only two letters. This is what regular grammar is. What I just said is given here. Later you can see. The left hand side of the rule has only one letter, and essentially it must be a non-terminal. A non-terminal means uppercase letter. Okay. Terminal means lowercase letter. On the right hand side of the rule, at the maximum, it can have only two letters or characters. Maximum I'm saying two. So minimum is one. Okay. One letter is, it can be lambda, it can be A, B, C, something like that. Okay. So what is the context-free grammar? Let us take an example. This is a context-free grammar. Why? On the left hand side, for a context-free grammar, still there will be only one letter. On the left hand side, still we will have only one letter. But on the right hand side, we can have one or more letters. I can have one letter, I can have two letters, I can have three letters, I can have 5, 9, 10, as many as possible. I simply say one or more. On the right hand side, I can have one or more letters. So, the difference between regular grammar and context-free grammar is, on the left hand side, the condition remains the same. We can have only one letter. That has to be a capital letter, non-terminal. For a regular grammar, on the right hand side, we can have one letter or maximum two letters. For a context-free grammar, on the right hand side, we can have one letter, two letter, three letter, as many possible. So I simply say one or more letters. So if you see here, in this grammar, here I am having three letters. So it cannot be a regular grammar, it is context-free grammar, CFG in short. Similarly, this is also a context-free grammar, because the S rule you see, we have more than two letters. I don't need to say 5 letters or 6 letters, I have more than two letters on the right hand side of this grammar. So it is context-free grammar. Okay. So now, coming to question 2, it says, for each of the following regular expression, write a regular grammar that defines the same language. So I am going to choose C. Why C means, if you, in a way, C and B, they are similar. If I can solve C, I can solve B. If I can solve B, I can also solve A. The concept is similar. Okay. So I'm going to look at this question, and I'm going to explain. So how to read this question? It reads like this. The language is A followed by A or B or C clenesta. Okay. And followed by B A or B or C clenesta. Okay. So I can actually rewrite this something like this. So what happens if clenesta takes a value 0? What will happen if clenesta takes a value 0? If clenesta takes a value 0, you will get A. This A will remain, because clenesta 0 means this part of the string is going to be empty. Okay, this part of the string is going to be empty. Clenesta 0 means the string made up of A or B or C has length 0 characters. Okay, so some of you might think A, you should read this as A followed by nothing, not A multiplied by 0. I'm not saying 0, I'm only saying the length of the string is of 0 characters. Okay, if this clenesta takes a value 0, it means the string made up of A or B or C has 0 characters, meaning empty string. So A followed by empty string. Okay, then B followed by empty string if clenesta takes a value 0. So you will get AB. Okay, so what happens if clenesta takes a value 1? Definitely we will have this A. Okay, A, and clenesta takes a value 1 means, it means this part of the string should have only one character, right? It could be made up of A or B or C. So I can have A followed by A, that is this A followed by A. I can have something like this. Okay, or I can have AB, A followed by B, or I can have A followed by C, correct, right? I can have A followed by C. Okay, I only looked at this part. Now I have B followed by A or B or C. So after this I can have B, I can have A, I can have B followed by B, I can have B followed by C. Okay, that is B followed by A, or B followed by B, or B followed by C. Because if clenesta is 1, then this part of the string should have only one character. Okay, so if clenesta takes a value 2, then I will have A followed by 2A, A followed by 2B, A followed by 2C. Need not be. It could be A followed by AB, it could be A followed by BA, it could be A followed by BC, or it could be A followed by BA or CB or CA, you know. That is, this part of the string can have 2 characters if clenesta is 2. So I can have A followed by 2A, A followed by 2B, A followed by 2C, or I can have A followed by AB, A followed by AC, or A followed by BA, or A followed by CA, you know. So different possibilities. Okay. So how to write the grammar? Very simple. I am going to write something like this. S is, this is a must, I cannot do anything. So I take the A. I am going to take this part as A, capital A. Capital A, then B. I am going to take this part as A. So I am going to write here, just for your understanding here, comments, I am putting comments, where A is equal to A or B or C. Okay. So what will happen to this A or B or C is actually here. Is actually here. If clenesta is 0, you will get okay, let me What will happen if n A star is equal to 0? What will happen when n A star is equal to 0? In this case, what will happen if n A star is equal to 0? What will happen to A? If n A star is equal to 0, what will happen to A? Lambda, precisely, absolutely. You will get empty string. What will happen if n A star is equal to 1? If n A star is equal to 1, then A can be equal to A or B or C, correct, right? So what will happen if n A star is equal to 2? You can then A will be equal to, it can be AA or BB or CC. Yes, precisely. It can be AB, AC, BA, BC, right? Anything we have missed? 1, 2, 3, 4, 5, 6 only. Yeah. Sorry? AB is missing, yeah, AB is missing. AB or AC or BA, CA is also missing. CA, 1, 2, 3, 4, 5, 6, 7, 8, done. To me, A or B or C, there are 3 letters, correct, right? So length is 2. So 2 power 3, we should have 8 possibilities, 8 possible strings where each string is of 2 characters in length. Okay. So next what will happen if n A star is equal to 3? N A star is equal to 3, then you can have A is equal to triple A, or it can be equal to triple B, or it can be equal to